Hello, good morning, good afternoon, good evening to all of you joining our seminar. This is our last presentation for this series, for the ninth series of International Plant Breeding Seminar, hosted from here from North Carolina State University. Thank you for joining. Please shout out in the chat where are you joining from. It's always nice to see what a broad audience that we have. We have the honor having with us Dr. Aurelio Aguiar from Suzano in Brazil. Aurelio has been working and has experience for more than 22 years in eucalyptus breeding and genetics. He has covered all phases of the breeding process, including developing breeding populations, evaluation, selection, and recommendation of superior materials. He has contributed to the registration of several clones and the protection of several of them in Brazil. He earned a master's degree from Universidade Federal de Lavras and his PhD from the Universidade de São Paulo. And he began his career in eucalyptus breeding at Aracruz Cellulose for 6 years, and then he moved into Fibria Cellulose, always in eucalyptus breeding. In 2019, he took an appointment as a forest improvement specialist at Suzano, where he has played a key role in advancing the company breeding programs. We have the very good luck and honor of having Aurelio here at NC State as a research scholar since 2023, and he has been working with us to develop strategies and methodologies to create more resilient eucalyptus clones, focusing mainly on the challenges posed by climate change. Aurelio, it is a great pleasure to have you with us. I'm going to stop sharing now, and you can start sharing your screen.
Okay, thank you very much. Can you see my screen?
It's coming. Yes, there it is. Thank you. Go ahead. You take it from here.
Okay, first, thank you very much for the invite. It's a pleasure to be here, and my goal here is talk about eucalyptus breeding in Brazil, and I give a big picture about the breeding program of eucalyptus that you that you have been in Brazil. Just can I turn off the camera or keep?
It is okay if you leave it on, no problem. I think it's fine.
Okay, so eucalyptus is the meaning of the words eucalyptus is meaning well, good, and calyptus mean covered or canceled. So this is because the bud, you have this part here, the flower before open is covered. So this is because that's because the name is because of this. It was a species from Australia. You have more than as a genus from Australia. You have more than 700 species, and you have other species from other island, Papua Nova Guinea, from Indonesia. So there is a lot of species, and this is very interesting for the breeders. And it was described in 70 years, the decade 1970 a year. I don't remember the right data. But why we use eucalyptus in a breeding program for produce pulp? This is interesting to mention that versatility. It's a wide adaptation. Eucalyptus can be planted in many places, considering different type of soils, environment conditions around the world, mostly in tropical areas and subtropical areas. And you can use pure species, and you can do hybrids between some species. So, and for the breeding, for breeders, we can clone it, the best individuals, so clone propagation and hybridization. So this is a nice tool that you can use in the breeding program. Other thing that is most important, it's so important, is fast growth. Eucalyptus has a big competitive advantage compared with other species. For example, eucalyptus in Brazil, the rotation age is average 6 to 7 years old. If you compare with, for example, southern softwood is at least 12 years old, the first thinning. Northern softwood at least 30 years old. So with eucalyptus, you can use less land to produce the same amount of wood. And other thing, it's important, is a product. Eucalyptus is a short fiber, 0.8 millimeters, high quality of product. You can produce high quality of tissue paper and other consumer goods. Other thing that is important that we developed in Brazil, it was a technical expertise. There is a lot of research that was done since Navarro de Andrade, that it was the first that guy introduced eucalyptus in Brazil. There is a lot of investing in forest research. We have some college of forest engineers and agronomists. We do a good work with genetics and breeding. We introduce a lot of species from Australia. We made breeding program. We studied breeding population. We developed new hybrids. We developed forest management adapted for Brazil. We developed protection techniques. For example, nowadays we produce a lot of natural enemies, considering the pests and diseases made for bugs, for example, in this case, but we develop protocols for inoculation for disease, for phenotyping. This has helped a lot in the breeding program. We develop techniques of propagation. We have mini garden large scale nowadays. Nowadays we planted just clones in the operational area. So we need to develop, and we developed a lot of techniques for propagation large scale. And also we develop a lot of works with sustainability that is so important, how we can plant it, where we can plant it, some mosaics, things like that. I'll show you in the future. Now, I show some slides about Brazilian forest sector. This is not my presentation. This is a presentation from Brazilian Tree Industry. This is association of the companies you have some nice data here. Just to give idea about the importance of this industry in Brazil. In 2023, by example, we exported almost $3 billion around the world. We are the largest exporter of cellulose. We are the second largest producer of cellulose pulp, and we export a lot to US and to China and Europe. Nowadays, there is a lot of investment in Brazil. At the last years, every 1.5 years, we have a new factory. So some ones are big, other not so big, and we are expecting more investment in the new future. Suzano had a new mill in Ribas do Rio Pardo. It was an investment. This is around 100 billion reais, is around $2 billion. So in the next 4 years, we invest this amount of money in many different mills or restoration of some mills. This is interesting. This slide, I like it. The production and protect areas in Brazil, we have around 66% of our area is preserved net areas with natural vegetation, and we have been using 30% of our area with agricultural production, and 1.2% is for forest plantation. This is not, we don't use a lot of land. Considering if you compare with US, 74% of the area, the land use is for agriculture production, is a little bit different. And now I talk more about Suzano and what we are doing there about breeding program. Our business is pulp, our big business. We have been producing 30.5 million tons per year. We have business in paper and packaging, 1.2 million tons per year. We have consumer goods, and we are evaluating new business considering fluff pulp and textile from the new future. Our mules, we have 100, the company has 100-year-old. Nowadays, we are planting 1.2 million eucalyptus seedlings per day. We have 1.6 million hectares of forest. I'll show this in the next slide. This is more detail. And we have 1.6 plantations, planted forest, and you have 1 million of hectares of conservation area. It's a huge area. So here is where we are in Brazil. We have a unit in Maranhão unit where we have more than 200,000 hectares of plantation, eucalyptus plantation. We have other big unit in Bahia and South Espírito Santo, south of Bahia and north of Espírito Santo. There we have almost 400,000 hectares. We have other units in São Paulo state, more than 200,000 hectares of plantation. And you have our huge unit is in Mato Grosso do Sul, where we have more than 600,000 hectares of plantation. And what is our challenges nowadays? The first one is climate change. I will give here one example about what is going on. For example, in Três Lagoas unit, in the last 33 years, the number of days above 35 degrees increased 62 days. In the past, it was around less than 30 days per year above 35 degrees. And nowadays, it's around 90 days above 35 degrees. So in the maximum temperature increased 2.31 degrees Celsius in these 33 years. You can see here in this density graphics, I made some groups each 4 years, and you have the last 4 years, you can see the temperature, the average is higher than the past. And the question is, are our clones truly resilient to the future climate conditions over the next 5, 10, or 20 years? Because in the breeding program, we look at the past and expect that these clones have the same behavior in the future, but you need to be careful. And we have a program, we are working together to do a breeding for resilience. And how we are doing this? First, we are expanding the genetic base. We have breeding population, we have synthetic population, we are using genome-wide selection, but we have other approaches. I will mention more about in the future, but we have other approach like DryMax project. It's an internal project where we are crossing the traditional species, eucalyptus traditional species, with other new species that is more tolerant for drought or for other problems. We are introducing new species like Corymbia, by example, from Australia, from Kencor here, or CIFI, it's an Institute of Research from University of Viçosa. We have a partnership with them. We are investing in phenotyping. We are using RGB images from drones in the breeding trials. The idea here is because nowadays we are doing early selection at 3 years old. The idea is change to a snapshot to a movie. The idea is have measure every 4 months, by example. We have a good zone environment. This helps us to do experimental plantings in areas prone to drought. We are evaluating root seedlings to help us to define if a clone is more susceptible or not for drought. We have a system that helps us to identify we call it climate fingerprint that show for us what happened during that time about the climate. We have field phenotyping for drought. We are using some scale, and we are developing and we are building a greenhouse for phenotyping for drought in São Paulo. And we work a lot with clone allocation. We combine zoning and the system I show more in the future about the system called Tetris that help us to do the best match between the clones and the environment that where we have where we need to plant the clones in the operational area. This is some pictures about Corymbia. Corymbia was tested in the past Nowadays, it's becoming more important because it's more tolerant, more resilient for some stress like drought. It's a nice species. There is a high basic density that is good, but you need to be careful with the thickness bark. It's much bigger than eucalyptus. And sometimes there is resin that is not good for the meal. But there is a genetic diversity for this trait, so we are selecting against the resin. This is other thing that we are doing. This is a work that we are doing here with CanCore. We created a scenario, a zoning, considering the past data, the actual data that you have from the climate. And after we created the cluster zoning, clusters considering the future climate. And there is some areas that is, we call it transition, that nowadays it's areas that maybe in the future will be different from the past. We using this information to create the new zoning area. We call it this transition, and this is help the plant breeding to plant more trials in this area, because you don't know how will be the behavior of the clones in this area, by example. And this is the cycle of the breeding, eucalyptus breeding. We started with the recombination. I will show you in the next slide about the seed orchard. And we have synthetic population. We have landrace population. We call it Eucalyptus susano. It's a hybrid between different species. And we're evaluating polyploids and other endogamy in the breeding, like self in the breeding program. And after, with the seeds, we are using nowadays progen clonal trial. In the past, we used the progen trial, and after we clone the trees, I showed to do more details in the future. In this progen clonal trial, we evaluate the growth, we evaluate wood quality, non-destructive approach. I show you something about it. We phenotype for some diseases when you select the best potential clones in this progen clonal trial. To the next phase, we phenotype for some diseases. And nowadays, what we are working is how we can use images to help us to identify, to select for stress, or to remove the discard individuals that are not so adapted for that condition. We divide the breeding cycle in two phases. We have a breeding phase and other clonal deployment. In the future, I'll talk more about clonal deployment. But about the seed orchard, we have manually crossing that happens in the breeding program. We have orchard in Bahia, São Paulo, and Mato Grosso do Sul unit. This is how we are manage our plus trees. And nowadays, the main species that we are using depends on the unit. For example, in Mato Grosso, we are using a lot of Eucalyptus grandis, Europhila. Nowadays, we are using more triticores because of the drought problems, Longirostrata, and other species. I forgot to mention that the main goal of the breeding program is to increase the May pulp, is the amount of air dry ton of pulp per hectare per year. And of course, we need to considering some limiting disease for each unit. By example, in Espírito Santo and Bahia, you have problem with fungus. By example, ceratocystis, that is a huge problem. The clones need to be tolerant or resistant for that disease. And Mato Grosso do Sul, we have problems with Erwinia bacteria, so we need to take care with this. So each unit has your particularity, and you need to take care of this. Just to give an example, to produce seeds between the induced protocol of flowering and the seed harvesting, at least 18 months. It's not so simple. It's a long-term work. And here I give idea about the progress of the program. In the past, we had the traditional pipeline where we have recombination, seed production, and we have progen trial And after we select the best individual we rescue this individual in the progeny trial and planted this individual in the clonal trial. So in the progeny trial, the individual is unique. In the clonal trial, we have a repetition, remits for these clones. We put this clonal trial in more environment, and after select the best clones, propagation again, and planted in an expanded clonal trial. And after recommended for semi-operational scale. Nowadays, we are using breeding approach, the recombination plus cloned progeny test or cloned trial. This is our present. So we have the recombination of the plus trees with the seeds. We cloned some individuals. I show more details in the future. And we planted this, it's a merge between the progeny trial and clonal trial. It's the size is big, but not so a progeny trial. And after we rescue the best clonal trial and plant in the expanded clonal trial. With this, we reduce 3 years in the breeding program, that gain 21% of time. In the next phase that we are working this, I hope this is the next generation in the breeding program, we'll do the recombination with the best plus trees. We are planning a kind of screening in propagation because I have a lot of seeds. It's too much. It's a lot of money to genotype all of these individuals we are building with genome-wide selection models. And after we planted a clonal progeny trial or expanded clonal trial, that depends on the number of individuals that we have, potential individuals. And after recommend to the semi-operational scale. With this, we reduce less years, 7 years, 50% of the breeding cycle. This is a paper that we published this year about this pipeline, how we can use cloned progeny trial and molecular data in the Eucalyptus breeding program. So here we have the scheme of how we produce the seedlings. It was in the field orchard. It's not in the indoor orchard at this case. We produce around 5 to 8 families, and we cloned around 6 seedlings per family. So we have a lot of clones, and we planted these clones in 2 places in Mato Grosso do Sul unit. There, we have sub-trials. We divide this in small trials. We use in alpha lat design, and it was a nice work. Here I have some results. We use different approaches to estimate the blubs, if I can say this. We use the matrix A, consider the pedigree-based relationship. We use the matrix AC because we reconstructed relationship, genome matrix, and use the matrix age, that it's the A plus AC. So the good information here is in these trials, it's important to mention, in these trials, we use 5 reps per clone. So we imagine one family, we select 60 individuals, we cloned all of them, and in the trial, we have 5 reps per each clone. So if you can see here, after 3 reps, the accuracy is so high. So in the future, maybe we don't need to use 5 reps. Maybe we can use 3. But sometimes use 4 because degree of freedom. And here is about the genetic gain. Their ability increased a lot, considering this different approach, the matrix that you're using to predict the genetic blobs in this case. And you can considering the gain, if you can compare with the traditional approach, the approach to progeny trial, cloned trial, and this is using progeny trial using just the A matrix. This is our benchmark AC matrix, and this is the progeny clonal trial using age matrix. We can see that the gain is very high, for around more than 40%, because we reduce a lot of the time. And in this case, we increase their ability. This is some results that we have in these trials. We select, for example, this is at 3 years old, and we have, in this case, we have around 3,000 clones, and you can consider, for example, the top 100 clones, the best 100 clones are around 6% better than our best trial, our best check in the trial. This is information about ranking. We evaluate this trial every year. The correlation between 1 to 2 years is not so high, but after 2 to 3 years, it's good. So we can do early selection. To me, 3 years is a good year to do an early selection. Earlier than this, we need to be careful. Now I talk more about the clonal deployment. So the expanded clonal trials, the operational scale, how we can do this. In this case, in this phase, we evaluated of growth and yield quality. In this case, the yield quality is not non-destructive, it's destructive. And we continue to evaluate the stress, but in the greenhouse, not in the field, in this case. And the operational scale, we try to do a better allocation considering climate conditions and the clone information that we have in the growth. And this is an example about Bahia and Espírito Santo. We have this kind of zoning there. So the red is prone to drought, and the blue is more humid area. So in this phase, we evaluated in more environments. We planned expanded clonal trials in many environments, and do with this information, we do this clonal allocation. And we evaluated the field trials at 3 and 5 years old to evaluate the growth and the quality and the interaction with the Bahia. And we select the best clones for maple and eliminatory traits. And after you do this clonal allocation using the Tetris system, I showed you something. One thing is that we are doing a lot, and that it's very important, is how we sell the new clones for the operational area. We have a process called Selection Suzano Genetics. We call it SGS. We combine science and experience. So every year, we do a meeting between the breeding team, the management team, the forest management, the research area, and the forest operation. We show them to the new clones. We show the results that we have about wood quality, diseases, phenotyping, disease, things like that, all information. We do some field trips. We visit the clones in the field. We see the results of the inventory data that you have in the research, in the trials that we have, and the inventory data from the operational area. And you define, for example, a clone that have been planted a long time. We define with them, no, let's remove these clones because they have problem with disease. The productivity nowadays is not so high with the last ones, with the new ones. And we created that proposal. And after, we have this system called Tetris that help us to allocate the clones in the best area that you need to plant it, that are ready to plant it. The main guidelines are the percentage of area each clone in each environment. We don't plant one clone in a large area. We need to respect, we have some numbers that help us to respect the amount of area that you can plant it in the field. We have this limit area per clone, per farm. And we created this kind of mosaic planting, and specific restriction for each clone is defined with this in the SGS. And after this system, help us to allocate the best clones in the best environment. We use the inventory data, we use soil information, climate data to help us to do this better match. Here's how the system works. And other thing that we are doing, it's testing how we can increase the we call it this insurance, is the clonal composite, because it's a kind of mix of clones planted together, but these clones are tested and selected to be planted together. They are genetically distinct between them, but phenotypically similar. We have a paper about this work. And here in this picture, you can see the plantation. This is operational plantation. We have many clones. You can see the difference of the color of the leaves. This is different clones. And here we have a monoclonal block. Our expectation is in this clonal mix, we have genetic diversity, and you can reduce the problem with new disease, for example. This is some data about the productivity. We use clonal composite is like insurance. I don't like to use, but if you need, it's there. I compare some farms where I have clonal composite and clonal block. In this case, BM1, it's environment, microenvironment. In this case, I have 100 farms. And in this farm, I have and I have some plots with clonal composite and clonal block. And in this case, 54 areas, 54 farms, the best productivity was the clonal composite. And the gain, the ratio of productivity, is 2% better than the monoclonal. So we can see here in BM1, BM2, and BM3, the productivity is almost the same, the composite and the monoclonal. So to me, it's a gain. In other areas, they're not so well yet because they're not so adapted for some stress here, but we are working to produce better clonal composite for these areas. About phenotyping tools, that it's very important. At the first time, we use volume and CAP, the circumference at breast height. We measured height also. So in the breeding trials, we measured the whole trees for circumference or diameter. The height we are discussing depends on. We use this equipment called piloting that helps us to estimate the basic density, wood basic density, that is so important for the meal in the breeding the process. We have been using NIR to predict the yield quality. We extract a core to the plant, to the tree, and we have some models to predict the wood quality traits. In this case here is for lignin. We have models for lignin, ratio, synergy and YSU, for pulp yield, and other traits that are important for the meal and the final product. And more recently, we are using drones to estimate the height in the breeding trials, and other how I can say, the other index of vegetation that could help us to select the clones more susceptible or more tolerant for stress. In this case here, you can see in the image, there is a line that all the line is red. In this case is the height, is the heat map. The problem here is that line was not fertilizer. So with image, we can see some informations that we cannot see in the ground. So we believe that image will help a lot in the future, not helping yet in the breeding trials. Another thing that is very important, that images can be outdated, because sometimes we receive data from the field, and if you made some analysis and you see some bad results, so need to review the data, things like that. We need to come back to the field, things like that. With the images, easier to to see again. We are in the third phase of the process of images. At the first time, we check if this image could estimate the height well. We do some check, we evaluate the prediction and the real value. Don't change the ranking, we need to be careful. RGB images is very important to ranking, not the absolute value. Here, and after we measure every 2 months to see if the image can capture the growth after this time, and it's possible. And now we are scale up this in Mato Grosso do Sul and São Paulo unit in large scale. This is other phase for phenotyping so important. We are doing this with Futuragene. It's a company from Suzano. We call it this project Phenomics. It's where we phenotyping the clones in the last phase for some bugs and diseases. Go wasp is a big problem. It's insect, but you have a lot of you can control with there is a tolerant or resistance and genetic diversity. Ceratocystis is a fungus. There is a problems in all over Brazil, but you have some specific race depends on the unit. You need to be careful with this. You don't have alternative control, just the genetic control that you have. Erwinia is a bacteria. We have a serious problems in the past in Mato Grosso do Sul unit and Rio Grande do Sul, that in São Paulo sometimes. And there is not a control in the field. We need to control using genetic material resistance. Houstonia is a problem in nursery, not in the field, but you need to take care. Other thing that is important, this is vascular, I forgot to mention. This disease here is vascular disease, and you have foliar disease. The worst is plant rust, mainly in the 6 to 7 month years. And after we have problem with scalonectria, that is a problem in Bahia, Mato Grosso, and Maranhão unit. So we're phenotyping for all these trees, all this disease with Futuragene team. And what we are doing, and here is together with Universidade Federal do Paraná, Kencor, Suzano, and CIFI, we are testing LiDAR. LiDAR is an amazing tool to estimate the volume, the diameter, the height, the precision, the accuracy is very high. The question is the price to collect this data is not so cheap, it's expensive. But we believe that with LiDAR, we can estimate some traits that we cannot measure nowadays. I believe that in the last phase of the breeding program, we can use LiDAR to estimate better the volume, the branch, and other traits that we are not estimating nowadays. Here, we are combining RGB and LiDAR, and you can see the canopy and other things that you cannot see nowadays. And here there is a list of traits that are measured with LiDAR. And we are testing nowadays with this team some algorithms to help us to extract this information. I'm almost finishing. This is some data about the evolution of the breeding program, the May pulp. In the last year, 6 years, we have serious problems with canker, rust, gold wasp, Ralstonia, Erwinia, Gonipterus, Glycaps, it's other bugs, Tomatocorus peregrinus, physiological disorder. It was a big problem that we have in the Bahia and state, Espírito Santo state. It was because the climate change. It was mainly the temperature at night. The minimum temperature changed the standard. We have a serious nowadays, the problem is more related with drought and hotter conditions. The solution, it was integration between the breeding and forest management team. We work together. So clonal propagation, clone resistance for diseases, natural enemies, clonal location, and innovation. So the last, by decade, this is the photo from the 7 to 8 years. The forests have probably shape, mortality, things like that. With the cloning and propagation, we have homogeneity, we increase the productivity. And nowadays we have more stress. At that time, we don't plant in large scale. Not, it was large scale, but not so large as now. But now we increased the maize cell. This is the air dry ton of pulp per hectare per year. So the last decade, the results. Other thing that is very important, it's data management. It is a game changer. We have nowadays in the company a manager guy that's responsible for this area. So imagine we have a lot of trials. In this case here, we have more than 1,000 trials in the field, planted in different units. We need to control when will these trials be measured, how they are measured, if they have the same pattern. So this is extremely important. So this helped a lot. This have been helped a lot, this area. Now this is the last slide, just to keep in mind that leading innovation is the sum of creativity and implementation. In the breeding program, we are very smart to create a new breeding population, new hybrids, new species, this kind of progen clone trial, clonal composite. We are working with environmics, molecular markers, but to become innovation, to become money for the company, we need to implement. So it's important to have this kind of SGS, the Tetris, transition nursery, work together with the team, interdisciplinary work. This is very important. Data management and other approaches. Just with this, we can select the best clones and you can plant the best clones. If you don't plant the new clones, we don't have innovation, we don't have gain. So this is very important to keep in mind. It's not just be creativity. We need to implement this how we can implement this creativity to transform this in innovation. In this case, is a picture in the Mato Grosso do Sul. It's a new clone in the field. So that is really matter. So that's my last slide. I think we thank you very much. Thank you for this opportunity. And I'm here to take some.
All right, Aurelio. Well, thank you so much. Very, very, very nice, comprehensive presentation. Yes, we already have a couple of questions in the chat. I'm going to start with a question from Anderson. And I'm going to add a bit because I have a related question. Anderson is asking, what are Suzano's main strategies in the face of climate change when you look at current versus future clones? And I'm going to add to that. Your breeding program takes 7 years, and then the best clones hopefully will be in production, I don't know when, but a few more years down the road, and then the farmers will harvest a few extra 10, 12 years. So basically, you're in the business of crystal balls. I mean, I say the business of how you do that?
That's our big challenge. But nowadays, I think we don't have the crystal ball, but we have some tools. What we are doing, we are using the models that we have considering the climate change, for example, and we are doing some partnerships and we are building some greenhouses to simulate the climate of the future using these new clones. And that is one tool that we are developing. We are trying to create it, for example, about hotter conditions. How was the limit of each clone considering the hot conditions? How many days above 35 degrees, for example, this clone support? So we are doing this internally and with partnership with some universities in Brazil and US. But it's not simple, it's hard. It's our big
Raul,
problem. Yeah.
thank you. Raul de la Mata, he's from Spain, is asking, based on your current results in terms of G by E, have you been able to match clones, well, the clones with the zones? Or maybe are you willing to select clones based on more stable performance across zones? So what is your balance? I mean, you select for a specific niche or you select for broader adaptation?
Yeah. For example, inside depends on the unit. For example, in Mato Grosso do Sul unit, you don't have a big interaction D by E. The correlation between the environments is plus than 0.7. So we can select stable clones for every unit. In Espírito Santo, but you have big interaction between units because you have limits, diseases, things like that is different. But for example, in Espírito Santo unit and Bahia and Espírito Santo unit, you have five micro environments. In general, the correlation between the interaction de Bahia is not so big. It's not so high. It's high. It's around 0.6, 0.7. Sometimes we can find the clones more specific for a region with more drought, prone to drought. And we have a problem, not a problem. It's our reality. When you plant the clone, stay in the field at least 7 years. Sometimes, if you analyze a clonal or a set of clonal trial, a net of clonal trial, and you find a clone more specific for one environment, maybe it's not a good approach to select this clone for that environment because depends on what happened during the life of that trial. Maybe the interaction is with the year, not between the climate conditions, the representative climate conditions. So we try to select more stable clones than specific clones.
Okay. Andika here asking, are there specific wood properties for different type of products and how you deal with those different requirements?
Yeah, when you talk with some big clients, they said for us, no, I would like, for example, for some traits related to morphology, number of fibers per grams, other traits. But we need to take care. We sell pulp for many companies around the world. So we need to define the minimum. What's the minimum trait relate that could be important, that is important for every client? So nowadays we select for basic density and pulp yield. It's important for us in the process. And we evaluated the morphology. Sometimes it's important for some clients or not, but we don't have a breeding program for specific clients.
Okay. So at the end of the process, you basically guide different clones that can potentially adapt. Okay.
Yeah, it's more, we need to
yeah.
produce wood first. We need to produce wood first.
Okay. Yeah. How much of Susano's productive area is cultivated with composites, clonal composites? And are there any specific recommendations on how to best cultivate those mixtures?
That's a nice question. Nowadays, you have around, I think, 50,000 hectares of composite planted mainly in Espírito Santo and Bahia. But we are increasing. We have new composite for Maranhão unit. I think it's a good opportunity to the breeders. Imagine at the end of the breeding program, the breeding cycle, you have a set of clones, potential clones. Imagine 10 clones or 15 clones. And you start to plant these in operational scale, semi-operational scale. And it's common, we remove 1 or 2, 5 clones. This is so common. So when you do this like a monoclone, we can lose some areas in the field. Imagine you plant a clone that you believe that is good, your phenotyping data show that is good, but maybe you have a problem with some disease, new disease, things like that, insect. When you plant this in composite, you don't lose the wood. You just lose one tree, or for example, if you have 10 clones in the mix, if every clone has a problem, it's 1%, it's 10%,
Sure.
but you have other compensation.
Sure.
So, and you do this kind of cleaning, we clean the composite during his life. Sometimes we remove some clones that are not good. So it's an opportunity to scale up the new clones in faster than in monoclonal also.
I think it's a clever tactic in front of more variable environments. Okay.
Yeah.
So
and I heard that some companies of soybeans are using it's a mix of lines.
Yeah, variety mixtures. Okay. Freddy Salazar is asking, have you done any heritability estimates, narrow cells heritability estimate? And the second part of his question is the reduction of breeding cycles using incorporating genomic selection is already a reality or just an assumption?
About the genome-wide selection, we planted the first trials with this progen clonal trial in 2018. We collect data every year, and we genotyped 8% of the individuals, and we build some models of genome-wide selection. We applied this model in this population. We select the mother trees, the potential plus trees using the additive effect. And now we are recombining these individuals. Our expectation in the next 2 years, we have seedlings from this new population. So now it's becoming reality, the use of genome-wide selection in our breeding program. And we repeat this for each unit. Each unit nowadays have a set of progen clonal trial in the field. And we are building the models for genome-wide selection.
Okay. What the type of database that you use for managing this complex data involving multiple tests, years, regions, traits? That's a question from Carla.
At the first time, imagine you planted a trial. And nowadays we are evaluating at 3 years old the height, by example, or the DBH. We collect data from every tree in the trees in the trial. We do analysis and select the best potential clones to be cloned, by example. And we come back there in the trial and evaluate it for basic density using pilodine, or we collect the core to estimate the wood quality properties using NIR models. So we need to have a system that can manage all this data. And after, we need the system that do a connection. Imagine this is a progen trial example, and we cut this tree, we call this individual, you became a clone. So we need to have a system that do this connection between the tree in the progen trial, the information of the family, the father and the mother, and after the connection in the clonal trial and the expanded clonal trial. So we have a team that work with this. It's not the breeders that are doing this. We have a team responsible for that IT team that help us with this kind of system that we have in the clone.
Sure. Okay. How you integrate species like Corimbia in your breeding program?
Corimbia, it's other genus. We have eucalyptus, you have Corimbia. And
so it's a completely separate, or
yes,
you cannot hybrid those.
We don't make hybrids. We have other breeding program for Corimbias. But
question from myself. I understand eucalyptus, you can self-pollinate them. Is it a possibility to reduce the negative load of genes to implement a generation of selfing from now and then? Is that a possibility?
We have some works with endogamy.
Okay.
Our results that I don't believe that you have a line of eucalyptus.
Yeah, no, but it's just a way of having the recessives expressed and taken
But we
out.
believe that one generation of endogamy, we can remove a lot of alleles.
Deleterious, yes.
Yes. And after we can create the new population, and we call it S1 with S1.
Yeah.
And this population would be nice to select new clones. We are testing this in the field, that it's a good opportunity because you can clone, because you have two ways to maintain an individual. You can clone or you have a parental line. In our case, you have you can clone that individual, but you can use this kind of tools, the endogamy, to help us to in this case, it's better to maximize the heterosis. That it's
Okay. Well, thank you, Aurelio. It's fascinating, all the work you guys doing. And amazing, completely very well impressed. Okay. Thank you for your time and for your presentation. And thank you everybody for joining. I know people is joining this seminar kind of in the middle of the night, kind of late. So that tells me that this seminar means something for a lot of people in the world, which is great. This is the last seminar of the series. Thank you so much for all of you that have participated, attended this series. We're going to have the 10th series starting on October 16th. And I want to ask everybody, and we're going to send a reminder message, to please consider volunteering to present your work here in this platform, or send us suggestions of people that you think it will be worth presenting their work, okay? It means a lot to us. It makes our organization much easier than having to go around the world online and look for presenters, okay? So thank you so much. I hope you guys have an amazing summer season in the Northern Hemisphere and winter season in the Southern Hemisphere. It's always great to be in touch. You will receive a closing message tomorrow where you have all the links for all the presentations. And thank you so much again, and have a great time. Thank you, Aurelio, okay?
Thank you very much, Carlos. Thank you.
All right. Okay, we'll see you. Bye.